Hello, hi. Myself, Dr. Vinod. I am working as Associate Professor in Marri Laxman Reddy Institute of Technology and Management. My subject is today, that is Basic Electrical Engineering. The topic names I am going to deal today is Voltage Division Rule and Current Division Rule. This comes under Module 1 in Basic Electrical Engineering. So, introduction for this. So, as we know that electric circuits are classified into two main types. That is, namely series circuit and another one is parallel circuit. This is done based on the arrangements of the components in the circuit. So here circuits basically we see that is series circuit and parallel circuit. Then what is series circuit? A series circuit is one in which the components are chain connected. That we call it as a series connection. While in parallel circuit is one which all the circuit components are connected between two common points. Series is they connected in chain form, while the parallel is connected between two common points. Series circuits and parallel circuits act as voltage divider circuits and current divider circuits respectively. So here in this context, I have to give a sentence in such a way that where the series circuit is correlated with voltage divider, whereas parallel circuit is related with current divider. First, let us go with voltage division rule. Let us go with the introduction first. So, in the voltage division rule, the shortly we call it as a VDR. That is VDR. That is a basic principle generally we use in electrical and electronics circuits to determine the total voltage. So, in electrical and electronics field, if we want to find out the total voltage, how much it is getting divided with the individual components that are connected in series, then we must go with voltage division rule. Okay. It provides a quick and simple way to calculate the voltage drop across each element without solving the complex circuit equations. So here I can tell whenever we have the voltage division rule, it can sustain us to give a simple way of calculation for the voltage drop without solving the complex circuit equations. The basic idea. So here the basic idea is whenever the resistors are connected to end across the voltage source, the same current flows through all of them. However, the voltage across each resistor depends on the resistance value. So, as we know that in series, current will be same. In series, voltage will be getting divided based upon the resistor value. So, that's what it is. So, voltage across each resistor depends on the resistor value, but the same current flow is seen through all of them. So, the larger the resistance, we see the larger the voltage drop, or I can say like greater the voltage drop. So in simple terms, we can say like voltage divides in proportion to resistance in series circuit. A series circuit acts as voltage divider. Just now we have discussed. It divides the total supply voltage into different voltages across the circuit elements. If you see this figure 2, the source is taken from tutorials.point.com. Figure 2, this shows the voltage divider circuit in which the total supply is V and the resistance, first one is R1, second one is resistance R2. So as we discussed, the voltage is getting divided in the series connection. So here if you see, the current will be same throughout the series connection, voltage is getting divided. So the voltage which we are going to find out across R1, that we call as a V1, across R2 we call it as a V2. This is the total supply voltage V. And here we have two resistances, that is R1 and R2. R1 goes with V1, R2 goes with V2. And the current through both the resistance is same, denoted by I. So once again I am repeating, the source we have taken from tutorials point. So in this circuit, already we have discussed R1, V1, R2, V2, the current is same. According to the Ohm's law, we have V equal to IR. So with respect to first parameter here, we have taken V1, that's why the current is same, R1 value, current is same. So V1 is equal to I into R1. And V2. V2 is, current is same, so same I value is dropped here, resistance value is deferred, so that is R2. The total resistance of the circuit is given as, total we have two resistances that are connected in series, that's why we have taken R equivalent resistance, when the total resistance is equal to R1 plus R2. Here we have R1 and R2. That's why the total resistance is given as R equal to R1 plus R2. This we have taken as equation number 1. So from here, let us go back once. So from here, I is common, right? So I is equal to, from here, I is equal to, written as like this. I is equal to V1 by R1, that is equal to V2 by R2. So the common I is put on the left side. So we are going to get I equal to V1 by R1, I equal to V2 by R2. That is equation 3. As I is equal, so straight away we can write V1 by R1 is equal to V2 by R2. From here, you can write from the equations 2 and 3, finally we are going to get with basic mathematics, we are going to get V equal to V1 by R1 multiplied with R1 plus R2. So what is R1 plus R2? R1 plus R2 is the total resistance. So from here, if we go with basic mathematics, we are going to get the V1 is equal to V into R1 by R1 plus R2. That we have noted as the equation number 4. So similarly, from the above context, we can write V equal to V2 by R2 into R1 plus R2. So this is for V1, this is for V1 R1. Similarly, we are going to get V2 R2. So from here I can write, that is V2 is equal to V by V. V2 is equal to V into R2 divided by R1 plus R2. That is equation number 5. So hence, from the equations, I can say like, the resistor in the series circuit is equal to what? Is equal to product of the value of the resistor and the total supply voltage divided by the total resistance of the series resistor. So let us go with justification of the sentence for the previous slide. So V2 is equal to the total voltage into that particular resistor multiplied by the total resistance R1 plus R2. If at all I am finding out the voltage V2, then I have to multiply the total voltage into that particular resistance where I am finding that voltage, that is R2 divided by the total resistance R1 plus R2. So similarly, V1 is equal to V into R1 divided by R1 plus R2. Means I am finding out the voltage V1. So definitely I have to multiply the total voltage into the particular resistor divided by the total resistance. Total resistance is what? As we have R1 and R2, the total resistance will be R1 plus R2. So for this equation we have given, for this sentence we have given the justification. So let us go with a numerical example. So here I am going with, find the voltage across R1 and R2 resistance in the circuit. So here I have gone with source voltage and I have the two resistance, that is 6 ohm and 10 ohm. 6 ohm is R1 equal to 6 ohm. R2 is equal to 10 ohm. Okay. So this is R1, this is R2. So here I need to find out the voltage across R1 and R2. What I need to find out? I need to find out the voltage across this, that is will be V1 and here this is V2. I need to find out V1 and V2. What is V1? V1 is voltage across R1, V2 is voltage across R2. What is R1? R1 is resistance, resistor 1, R2 is resistor 2. So solution, let us go with the solution. So source voltage, this is R1 V1, this is R2 V2. So we have already the equation, already we have derived from the voltage division rule. So R1 is given by, voltage across R1 is given by V1 is equal to the total voltage into that particular resistance divided by the total resistance R1 plus R2. The total voltage is 12, particular resistance is, that is R1 divided by the total resistance, that is R1 plus R2, that is 6 plus 10 is equal to 4.5 volts. Next, the voltage across the resistor R2 is given as, we have the formula, that is voltage 2, that is V2 is equal to total voltage, that is or source voltage multiplied that particular resistor. What is the resistor? Resistor is R2 divided by the total resistance, that is R1 plus R2. So 12 into 10 divided by 6 plus 10 is equal to 7.5 volts. So this is all about the voltage division rule. Next, we are going for current division rule. So in current division rule, this is the basic principle. So determine the total currents, how they are getting divided in the parallel branches. So already we have discussed the voltage division rule that is related to the series connection. So next we are going for current division rule, that is dealing with the parallel branches or parallel connections, how in which the current is getting divided in those. Here resistors are connected in parallel. Okay, so the voltage across each branch is same. In voltage division rule, if you see, the voltage is getting divided in the series connection, the current is same. Whereas in parallel connection, voltage will be the same, but the current is getting divided. So the current division rule is applicable in parallel connections. So in simple terms, I can say like current divides inversely proportional to resistance in parallel circuit. Whereas in voltage division rule, that is for series circuit. So a parallel circuit acts as what? Current divider. So if you see here, this is a source current, or I can say like the total current. Current is getting divided for resistor 1 and resistor 2. So whatever the current that is referred to this particular branch, we call it as a I1. Similarly, this is for I2. The total current is I. So I divided into the currents, that is I1 and I2. I is coming like this, it is getting divided I1 and I2 into two parallel branches, where the resistances are R1 and R2. Although we notice that the voltage drop across the both resistance is same. So in parallel, the voltage will be same. Here voltage is same, the same voltage we see here. So in this circuit, according to the Ohm's law, I equal to V by R. So here in parallel, what is happening? Voltage is constant. So current is getting divided. So here I1 will be equal to V by R1, I2 is equal to V by R2. Okay, I1 is equal to V by R1, I2 is equal to V by R2. So we need to find out the equivalent resistance. There in series connection, total resistance R is equal to R1 plus R2. Here the total resistance will be equal to 1 by R is equal to 1 by R1 plus R, 1 by R2, because these are in parallel. So obviously from here I am going to get R is equal to R1 R2 divided by R1 plus R2. This is equation number 1. Also from the circuit we get I equal to V by R. V is, we know what is R. R is the total resistance, that is 1 by R is equal to, this is R, this is 1 by R. Here I can say like V by R is equal to V into 1 by R. So 1 by R, this will be reverse, this will be reverse. So that is R1 plus R2 divided by R1 into R2. That is equation number 2. But we know that the voltage across the both resistance is same. So voltage is same. So I1 R1 that will be equal to I2 R2. Similarly, the same case we have seen for voltage division rule also. There the current is same. That's why that equation I have received. Here the voltage is same. That's why we receive this equation. V equal to I1 R1 is equal to I2 R2. Hence, from above equations, we finally get I equal to I1 R1 into R1 plus R2 divided by R1 into R2. So finally, I am going to get I1 is equal to the total current into opposite resistance divided by the total resistance. So here, if I wanted to find out the current in the first branch, then I have to multiply the total current, that is I, into the opposite resistance, that is R2, divided by the total resistance, that is R1 plus R2. So here similarly we are going to get I equal to I2, similar, say the same thing, divided by R1 into R2 multiplied by R1 plus R2. So I am going to get that is I2 into R1 plus R2 divided by R1. So finally I am going to get, as we have seen, the I1, the current in the first branch, similarly the I2, that is the current in the second branch, I2 is equal to total current into the opposite resistance, that is R1, divided by the total resistance, that is R1 plus R2. So from the above equations, let us go with the previous slide. This is equation number 4, this is equation number 5. From equation 4 and 5, we are going to get the expression for the current division rule. So finally the statement can be concluded from here is that it is like current in any parallel branches is equal to the ratio of opposite branch resistance to sum of all resistance multiplied by the total circuit current. So I2 is equal to I into R1 divided by R1 plus R2. Similarly, I1 is equal to I into R2 divided by R1 plus R2. The summary, the conclusion for the concluding points for voltage division rule and current division rule. A parallel circuit acts as, definitely a current divider circuit, whereas it divides the total circuit current in its all branches. So a series circuit acts as voltage divider circuit, where it divides the total supply voltage in different voltage across various components of the circuit. The current division rule states like current in any of the parallel branch of the parallel circuit is equal to ratio of opposite branch resistance to the sum of all the resistance multiplied by the total current. So next summary point, the last one, that is voltage division rule, states like the series components, the series circuit is equal to product of the value of the resistance and the total supply voltage divided by the total resistance of the series circuit. This is all for today's class. Thank you.